Hello, everybody. This is Professor Kim. We're going to continue from multiplying binomial times binomial in radicals. And last time I talked about that we're going to do the foiling it. So when you have radical 2 minus 3 times radical 2 plus 4. When you have this, we are going to distribute radical 2 with a radical 2 and radical 2 with a radical 4, and then negative 3 with a radical 2 and negative 3 with a 4. So we're going to FOIL them. Or I will distribute first one with the twice and second one with the twice. So if we do that, radical 2 times radical 2 plus radical 2 times 4 and negative 3 times radical 2 and negative 3 times 4. Whenever you have multiplication of two same number, it become a number without the radicals. So this thing become 2 plus 4 radical 2 plus negative 3 radical 2 plus negative 12. Now you have a like terms in the middle, so, and here is a two integers. So you're going to group 2 with a negative 12 and 4 radical 2 with negative 3 radical 2. So you end up with a negative 10 plus 1 radical 2, which is negative 10 plus radical 2. Okay. So that's the answer. So here is a mistake. It should be plus. Now the second one is radical 3 plus radical 5 multiply with radical 3 minus radical 5. So I'm going to FOIL this again, or distribute twice with the first term and distribute twice with the second term. Then radical 3 times radical 3 plus radical 3 times negative radical 5 plus square root of 5 with the square root of 3 plus square root of 5 with negative square root of 5. When you do that, this will become 3 and negative square root of 15 and positive 15 and negative 5. So these two cancel out. You end up with a 3 plus negative 5, which is negative 2. So that's your final answer. Same thing goes with when you square them. So that's number 3. And number 4, when you have radical 2 plus radical 3 squared, in other words, that means you're multiplying radical 2 plus radical 3, multiply with a radical 2 plus radical 3. So you are multiplying self twice. So you're going to do the same thing. FOIL, or first term with a 2 distribution and second term with a 2 distribution. When you do that, you get square root of 2 times square root of 2 plus square root of 2 times square root of 3 plus square root of 3 times square root of 2 and square root of 3 times square root of 3. So that ended with 2 with a square root of 6, square root of 6, and 3. So two integer, you group them together and you group the radicals together. So you end up with 5 plus 2 radical 6 as your final answer. Or you can use the formula of a plus b squared equal a squared plus 2ab plus b squared and make a as a square root of 2 and b as a square root of 3. So you can do by the formula way as well. Now I want you to try this exercise 5, this question, and then check your answer with the answer key at the end of this section. Now, how about the division of a radical expression? When you have nth root of a over b, that's the same as separating numerator and denominator. So nth root of a divided by nth root of b. Or vice versa. When you have nth root of a divided by nth root of b, you can put them into one roof. Only thing you have to watch out when you do division of radicals, you are not supposed to have a radical at the denominator. So if you do have that, you have to rationalize it by multiplying additional top and bottom with same value as the denominator. At least that's the common way. So if you have a 2 over radical 3, then you cannot have a radical 3 in the denominator, so you multiply radical 3 and radical 3 top and bottom. You end up with 2 radical 3 with a 3. So whenever you have a 2 radical 3, end up with a 3. Now when you have a radical 3 divided by radical 5, because your index of the radicals are same, so you put into one roof. Okay. Oh, if you do that, you go nowhere. So that's not the way of simplifying it. Another way would be rationalizing it. Multiply by radical 5, radical 15 over 5. Or you can say 1/5 with a radical 15. Either one is fine. Because when there is nothing in there, that means there's always 1 in front of it. Okay, so it's 1/5. Now, when you have square root of 2x divided by square root of 7y, again, you cannot have a radical at the denominator. So you multiply square root of 7y top and bottom. Then you get 7y in the bottom and on the top. 2 times 7 is 14 and x and y. So that becomes your final answer because you cannot simplify any further on this. Number 4, 5 over radical 2, you multiply radical 2 and radical 2 top and bottom. You end up with a 2 in the bottom and 5 radical 2 on the top. Number 5, same thing. Well, it's not the same thing. What they did was they combined them together because they find out that 3 and 6 can reduce as 1 over 2. And then you separate them into radical x over radical 2y, and then you multiply radical 2y, radical 2y, and then 2y on the bottom, on the top become square root of 2xy. Now, what if I do this in another way? What if I just multiply radical 6y on the top and bottom first? What's going to happen? Then bottom becomes 6y and top become 18xy. So it looks like it's simpler in that way, but this is not the end. You can simplify further because 18 contain square root of 9 and square root of 2. And square root of 9 is 3, right? So you end up with a 3 radical 2xy over 6y. And 3 goes 3 once, 3 goes 6 twice. So you end up with a 1 square root of 2xy over 2y. Or just square root of 2xy over 2y. Okay, so you can write like this or like that. So whichever easier for you, you can do that. When you have number 6, square root of 12 over square root of 16a, put them together because you know you can reduce them. 4 goes there 3 times, 4 goes 16 4 times. So you end up with 3 over 4a. You have nothing else to reduce, so now you separate them. And then you realize square root of 4, you can come out as a 2. Now you're going to try to get rid of square root of a, so you're going to multiply square root of a in both sides to rationalize it. So if you do that, then this is a mistake. So you will have square root of 3a over 2, and square root of a and square root of a become a. So that's the final answer. I'm going to show you this in multiply square root of 16a in both sides. The bottom will be 16a, but numerator become square root of 12 times 16 times a. So 12 and 16 can be reduced further. So 12 is 4 and 3. 16 is square root of 4 and 4. So every square root of 4 come out as a 2. So you write this as a 2. So 2 radical 3, 2 radical a over 16. And you have a 3 2's, right? 2 to 3 is 8. So 8 radical 3 and a, that's inside, and 16. 8 goes 16 twice, 8 goes 8 once, so radical 3a over 2. So if you think this is easier, then you can do this way. Now, if you can, try the exercise 6 and check your answer with the solution key. Here is a exercise answer key for all the exercise. So at this video, we talked about foiling radical expression, and also the division of radical expression, especially when radical comes with a denominator, then you have to rationalize them. Okay, so that's it for today, and I will see you in a class. Okay, talk to you soon. Thank you.